Hello, my name is Jared Skeens and welcome to the Zoom room. Today we would like to start our series on the Statistics 1 Cambridge Math curriculum. So here we are, Statistics 1, data representation, location, and spread. These are actually the first 3 chapters of a Cambridge textbook. I combine them into one unit. And so data representation, and by the way, this is also the old terminology that they used in the older syllabus. Representation, location, and spread. The newer syllabus uses the terms data representation, measures of central tendency, and then measures of variation. And while that sounds more educational, as far as mental connection, I actually prefer the older terminology. So I'm going to stick with data representation, location, and spread. And we're dealing here with part 1, the stem and leaf plot. Now I'll get back to the stem and leaf plot in a second, but just to give you an idea of what we're looking at in this unit, data representation has to do with representing data graphically. So we're going to look at 4 different graph types: the stem and leaf, which we'll look at in part 1, box and whisker plot, histogram, and cumulative frequency graph. And then data location, or the measures of central tendency, we're going to look at things such as the mean and the median. Those are locations from which the data, those are specific numbers that kind of represent the data as a whole. And then the spread, or measures of variance, is how the data is spread out. Is it all bunched up in one group, or is it spread way out? So the variance and standard deviation have to do with the spread of data. So that's what we're looking at in this unit. And we're starting off with data representation. And our first way of representing data is going to be the stem and leaf. I used N as abbreviation for and, so stem and leaf plot. But before we get into how to draw it, there's a few things, few vocabulary words and concepts that we need to go over first. One of those is the 5-number summary. That is, all the data, whether it's a little bit of data or a lot of data, can be represented by 5 numbers, a 5-number summary. So 5 key numbers that can be used to help us with our understanding or diagramming of a data set. Number 1 is the minimum value. So that's the smallest or least value in the data set. Number 2 is quartile 1. Quartile 1 is basically the same thing as 25%. So it's like quarters. One fourth is 25%. So quartile 1, it's also abbreviated as Q1, capital Q with a 1. Then we have the median. The median is like the middle. So where is the middle of the data set at? And it can also be referred to as Q2, the second quartile, and it is your 50%. And then we have quartile 3. Of course, quartile 3 would be 75%. And then we have the maximum value, which is the highest number in the data set. And actually, this one would represent Q4, although we never really call it Q4, but it would represent then having 100% of the data in front of it, and it's the last one. So here's the first value. Okay, so actually, if you wanted to, you could call it 0%. In other words, there's no values in front of it. Quartile 1 has 25% of the values in front of it. Median is 50%, right in the middle. 75%, and then the last value maximum is 100%. So minimum, Q1, median, Q3, and maximum. Then if we're talking about the interquartile range, inter means between, so between the quartiles. Now the quartiles that it's specifically referring to is quartile 3 and quartile 1. So the interquartile range is how far is it between the third quartile and the first quartile. So you take Q3 and you subtract Q1, and that value is the interquartile range. Now this part down here we'll get to later. It has to do with our stem and leaf plot. Now this sounds relatively simple. I mean, 1/4 is pretty easy to deal with, and 25%, 50%, 75%. Those are common percentages that we work with regularly. But I find that students actually get tripped up a little bit by this. So what I want to do is I have some simple examples here, simple examples of the different variations that you could possibly run into. Now, you could be dealing with data sets of like 30, 60 values. I just picked a smaller sample set. I just numbered it 1 to 9, 1 to 10, 1 to 11, 1 to 12, just so that you can see how this works. You don't need to work with the percentages. In other words, you don't have to go 9/4 and get 1/4 of 9. Practically, there's a little bit easier way to do this than to work with percentages. First, your median is 50%. 50% means you're right in the middle, okay? Then your 25% is the middle of that first half, and the 75% is the middle of the second half. So you want to take a data set, break it in half, giving you 2 halves, and then break those in half, and you'll have your answers. But there's a little bit of a trick to it. So let me demonstrate it on here. So take good notes. Remember, if you are like one of my students, following along with the mental notes that I provided for you, use that space in the mental notes to help you learn how to do this correctly. I see too many students make mistakes on these quartile issues or questions, and they miss very simple points to get. So we want to clean that up and help you get the right values. So let's start with 9. Now, if you take the first even number, if 9 is an odd number, right? So if you take the first even number in front of it and divide it by 2, because we're going to look for the median first, that means 4. So notice if you go 4 from this side and 4 from that side, if you have an odd number, you have an exact middle. So 8 divided by 2 is 4. You get 4 on this side, 4 on this side with an exact middle. So if you have an exact middle, that is your median. Now, our 2 halves are comprised of 4, which is an even number. And if you divide an even number in half, so that we can find the quartile, here we have 4. If we divide it in half, we end up right here, 2 and 2. So if you don't end up on an exact number, what you need to do is average the 2 numbers on both sides of that little dotted line there. So 2 and 3 would make 2.5. So that then is our quartile 1. And same thing over here, we have 4 values. So right in the middle, 2 and 2. So we get 7.5. And that is our quartile 3. And then the minimum and maximum are easy because it's just your first and last number. By the way, all your numbers need to be put in order. You don't just take the data set as it's given. You need to arrange it from smallest to largest, and that's where the stem and leaf plot will help us, because data doesn't just come in nice orderly fashion for you. When you get data, it's just, here's the numbers, work with the numbers. So we need to organize them so that it's easier for us to analyze the data set. So when you get your group of numbers, you're going to order them from least to greatest, and then you can do your quartiles. So don't do the quartiles until you've put them in order. So then obviously the 1 here, that's our smallest, that's our minimum, and the 9 is the largest, that's the maximum. So here's 1, 2, 3, 4, 5 important numbers. 1, 2.5, 5, 7.5, and 9. That is our 5 number summary of this particular data set. Okay, well, let's move on. What if we have an even number of values? So we have 10. Well, if you divide 10 by 2, you get 5. So notice here's 5, the first 5, and the last 5. There's not an exact middle like we had before. So that means our dotted line is between the 5 and the 6. So we need to average those, and we get 5.5. That is our median. But we did not circle either the 5 or the 6. That means the 5 is still a part of the first half, and the 6 is still a part of the second half. Unlike up here, the 5 was the exact middle. It was neither on the left nor on the right. It is the exact middle. So here, our middle is 5.5. So the 5 is still a part of the first half. The 6 is still part of the second half. We have 5 values. So again, the first even number in front of that's 4. Divided by 2 is 2. So if we go 2 from both ends, 2 this way and 2 this way, notice we have an exact middle. So this is our Q1. And then these 5 also have an exact middle. Go 2 in from both sides. You have an exact middle, 8. So that's Q3. And again, 1 is your minimum and 10 is your maximum. So 1, 3, 5.5, 8, and 10. That's your 5 number summary. Okay. Now, notice not every odd and even set follows this exact pattern. So let's look at 11. So if we have 11, the nearest even number right before it's 10 divided by 2 is 5. So if we go 5 in from both ways, 1, 2, 3, 4, 5, odd numbers will have an exact middle. So 6 is our median because we went 5 and 5. So the 6th term is the exact middle. But instead of having an even number on both sides, now we have an odd number on both sides. 5 and 5 instead of 4 and 4. So with an odd number, okay, so we have 1, 2, 3, 4, 5. So the first even number in front of 5 is 4, divided by 2 is 2. So if you go 2 in, here's your 5, you have an exact middle. Go 2 in from both sides. So this one is your Q3. Here's 5. There's the exact middle. That's your Q1. Here's your min. Here's your max. So on this one, every single value was in the data set. Notice up here we had values that aren't technically in the data set, but they still represent quartiles, the 25th and 75th quartiles in the median, the 50th percentile. So here we have 1, 3. So 6 had 5 and 5. Then the middle, exact middle of those 5, and then the min and max. So min, Q1, median, Q3, and maximum. These are going to be important for you because after you make your stem and leaf plot, a lot of times you have to work with these values. So you got to be able to find them. And you have to find them in larger data sets, like I said, from 30, 40, 50 values. So you need to make sure you have in your mind how to do it. Now here's a group of 12. 12 divided by 2 is 6. So here's 6 and here's 6. There's not an exact middle. So again, you average the two numbers, so you get 6.5. That's your median. And the 6 and 7 are not circled, so they're still part of the first half and second half. So here we have 6, which means 3 and 3. Again, we don't have an exact middle, so we have to average those. 3.5, that's your Q1. This 6 doesn't have an exact middle either, 3 and 3. So this makes 9.5. Add them together, divide by 2. So 19 divided by 2 is 9.5. That's your third quartile. And then your min and max 1 and 12. Of course, your min and max will always be numbers from your data set, but notice your quartiles and even the median do not have to be actual data set values. So they can be an average of the two nearest numbers. So this is important that you understand how to get those values because you're going to be working with them. And then when we get to part 2, the box and whisker plot, you're going to actually be using these values to create your box and whisker plot. Okay? So then once you have these numbers, a very common question that it asks you is the interquartile range. So the interquartile range is the range of values between Q3 and Q1. So 7.5 minus 2.5 is 5. So your interquartile range is 5. And then on this one, your interquartile range is from the 3 to the 8. So 8 minus 3, that one also happens to be a 5 on that. And then here on our interquartile range for this one, it's from 3 to 9. Okay, 3 to 9, our interquartile range. And on this one, we get a value of 6, 9 minus 3. Q3 minus Q1 is a value of 6. So that's the interquartile range there. And on this one down here, we're from 3.5 to 9.5. And so when we subtract that, we also get 6 on this particular one. Q3 minus Q1 is your interquartile range. Okay, so these are the terminology that you will be working with, and you need to know how to find those. Very important. It's just small details, not worth a lot of points, but I see too many students mess up on finding those values, and it's sad to see people lose those little simple points when it's not really that difficult to do. Okay, so let me get set up for our first problem, and we'll look at stem and leaf plots. Okay, for our first stem and leaf plot, actually I'm going to share the screen and show you the Cambridge question, because the Cambridge question for this one provides the stem and leaf plot for you. So at least you can see what it looks like and the characteristics that you need to make sure you include when you're making your own. So let me share the screen here. And here we have our stem and leaf plot, okay? So notice it says the following back-to-back stem and leaf diagram. Now what it means by back-to-back is this here, if you look at my cursor, this here is the stem. And then going out from the side are the leaves. So going to the right is our natural direction of writing numbers. And when you've got two sets of numbers, then you start from the middle and you go out towards the left. So A is kind of like going in the opposite direction. It's going from the center to the left. B is going from the center to the right. this is called a back-to-back stem and leaf diagram. Now, sometimes you might only have a one-sided stem and leaf diagram if you only have one data set, but usually they'll probably give you two data set and ask you to do this back-to-back stem and leaf. So what you're looking for the stem, which is the main part of your graph here, is you're looking for values that every number in your data set has in common. So that would be the twos. All of these data sets have twos here. And then, and it even could go up to 19 where the one isn't necessarily shared. But the second number is not shared. That's the tens, or this second value here. So you have 20, 21, 22, 23, 24, and 25. But this 20 is shared by all the numbers in this row. The 21 is shared by all the numbers in this row. The 22 is shared by all the numbers in that row, and so on. So this is the stem going from 20 to 25. The leaf are the 5, 6, and 7. Those are individual numbers. And then over here you have 1, 2, 2. Notice when the data is repeated, you still put the 2 in twice. 1 for each time it occurs. Also, you see the 7s occur twice. Here you see 9s, 3 of them. So there's a 2, 3, 9, 2, 3, 9, 2, 3, 9 that occurred 3 times. Now, to understand what this means, notice you need to have labels. So labels is important. This is group A, this is group B, so make sure you put your labels in. Also, these numbers over here aren't necessarily required for you to do, but it is a good idea to put it. It can help you find your quartiles a little faster. So there's 3 data points. There's 3 entries here. So that's why there's a 3 over here. Notice on this side, there's 4. 1, 2, 3, 4. So there's a 4 over here. And this one, there's 6, and then 7, then 8. So notice it says, it doesn't really say how many there are. So you actually have to add these up or count one per one how many there are in the group. Then down here is the key. Make sure you remember when you're making a stem and leaf plot that you're providing a key. So what this is just one particular sample out of the graph. So this 522.6, it comes from, well, here's the 22 right here. And there's a 5 over here and a 6 over here. So they take one of the stem and a leaf from each side, and this is the key to tell you what it means. So a 522.6 with the 22 as the stem and the 5 and 6 as a leaf means it's a reaction time of 0.225. So notice there's a decimal in front of these numbers that you don't see in the stem. And so in the data set, you actually had a 0.225. So they just put the 22 for the stem and the 5 over here on the left. So that would be this 5 right there. And then 226 means 0.226. So here's the 22, and it's one of these 6's here. 0.226 is for, again, the B. So your key helps to identify the place values. Are we dealing with 0.22? Are we dealing with 225, 226? Are we dealing with thousands? So the key is very important for establishing the place value of these numbers that are grouped together in the stem and leaf plot. So notice it says to find the median and the interquartile range for group A. So here's group A. The median is the middle, that's quartile 2. Interquartile range is Q3 minus Q1. So what we need to do is we need to add up these values here and find out how many are in group A. So here we have 4 and 7 is 9, 9 and 8 is 17, 17 and 6 is 23, 23 and 3 is 26, and 1 is 27. So I'm just going to write 27 here on the board. And if you want to, you can double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. You can count them up one per one, or you can use your calculator to do this if you don't trust your mental math. But we have 27. So the even number right before that's 26. So that means we're going to get 13 and 13 on a side with one exact middle, okay? So we get 13 on both sides with an exact middle because it is an odd number. So to help us find what we want is then the 14th number. 13 on each side with the 14th one being right in the middle. So if you look at the side here, instead of going one per one, you can look at the side and say there's already 9 right here. 9 plus 8 is 17. That means the 14th one occurs somewhere in this row. Now we're dealing with the left-hand side. That means we have to count outwards from the stem. So this would be our minimum, the 0.200, 0.200, that would be the minimum, and then 0, then 2, then 4, then 0.210, and going this way. So here's 9 already. That means this 2 here is number 10, number 11, number 12, number 13, and number 14 is this 5. So the 225 happens to be our median, the middle one. If you count this way, which if you're counting from the top end, you would count from the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You still get to the same number. Okay, so this 5, it's probably easier for you to count from the smaller one up, but that's the number 14 out of 27. So our median then is 0.225. Okay. Now, on your paper, you'll probably want to circle that. Since this is on the computer, I can't circle it, but keep track of that. Now, that means we have 13 numbers in front of it that going this way. 13 numbers right here. Those 4, these 5, and these 4 here. So that means 13 is also got an exact middle. So the even number before 13 is 12, divided by 2 is 6. So you have 6 and 6 with an exact middle, meaning it's the 7th value. So 1, 2, 3, 4, 5, 6, 7. It's this 5 here. So Q1 is 0.215. So notice 1, 2, 3, 4, 5, 6, 7. Or if we counted backwards from here, 1, 2, 3, 4, 5, 6, 7. Same either way. Okay. Now we need to go to this half and we need to count 7. So we don't count the 5 because it was an exact middle. So we start with the 7. 1, 2, 3, 4, 5, 6, 7. So Q3 is 0.236. So I write that down. Q3 equals 0.236. We know it's 0.23 because we looked at the key, tells us the decimal there. If we go backwards, again, if you go backwards, you have to count from the right because you're going from biggest down. So 1, 2, 3, 4, 5, 6, 7. You still end up at the 6 there. Okay, so that's our Q3. So to find the interquartile range, so now I will stop sharing and come back here to the board just in case you couldn't see my writing. So notice I counted the A group had 27. So the even number right before that's 26, divided by 2 is 13, with 1 for the exact middle. So that meant that we are looking for the 14th value for the median. Okay, the 14th value is the median, which was 0.225. Then those 13, when you divide them by 2, those split down into, let me get rid of this, those split down into the even number before 13 is 12, divided by 2 is 6. So you have a 6, 1, 6. So 12 plus 1 is 13. 6 and 6 with an exact middle again. And this would be from the median, this would be the 7th term in for both of these, the 7th term from the minimum. And you could also, if you want to go backwards from the maximum, 7th from the maximum or 7th from the median, 7th from the minimum, or you could count backwards 7th from the median. Okay, it's all in there. So you're looking for that exact middle, and we got 0.215 for the Q1 and 0.236 for the Q3. Now we want to find the interquartile range, which is Q3 minus Q1. So 0.236 minus 0.215. And that equals 0.021. So 0.021 is our interquartile range. So again, on this case, they provided the stem and leaf, a back-to-back stem and leaf for you. Makes it nice for us to look at it and see what it's supposed to look like. Remember labels, so you had group A and group B. Also remember to make a key. So labels and key are important to gain points for your stem and leaf. And the key then, if it's a back-to-back, you need to show both sides. Just take a random selection from your chart. 315 is, I just made up these numbers. So 1 and 3 make 13 for group A, 1 and 5 make 15 for group B. Of course, in this case, it had decimals in it, and it provided that in the key. So make sure that you're showing that in your stem and leaf. So now that we've talked about it and seen it, now it's time for us to do it. So let me set up the second example for us to look at. Okay, here we're back. Let's go right to our screen share so that we can see this next problem. Notice they do not give you the stem and leaf. Instead, they give you this 2 sets of data. It says the heights are in centimeters of the 11 members of the Anvils of athletic team and 11 members of the Brecken's swimming team are shown below. So if you look at Anvils, the numbers are random. They're not in any particular order. For the Brecken's, the numbers are in order. So it says to draw a back-to-back stem and leaf diagram to represent the information with Anvils on the left-hand side of the diagram and Brecken's on the right-hand side of the diagram. So generally, it doesn't matter which side that you put them on, but here it specifically asks you for the Anvils on the left and the Brecken's on the right of your back-to-back stem and leaf plot. So what you want to look for, notice all the values have that 1, as in 100, in common. So that obviously is going to go in the stem. And then with it, you also want the first number that changes. So, or since this is a 3-digit numbers, we'll take 2 digits to put in the stem and the last number to put in the leaf. So notice here with the Anvils, we have a 15 for our 158. So the first 2 numbers are 15. Here over here, we have a 16, we have 17, we have 18, and we have 19. There's no 20s, there's no 200s. If there was a 200, it's okay, you can still make 20. That first digit doesn't have to all be exactly the same. And then for the Brecons, it goes from 16 to 19 as far as 160s to 190s. So what you want to do is to start to put it into order on your paper. So let's go back to the board here. And you can see that that is what I've done. I've put the anvils on the left, the Brecons on the right. So here are our labels. Labels is you get 1 point. If you don't put labels, you lose a point. So make sure you do labels. Choosing the right stem. So it was 3-digit numbers. So we put 2 digits, the first 2 digits in the stem, and we're putting the 3rd digit as the leaf. So when we look at the first 2 digits, it went from 15 through 19. So 15, 16, 17, 18, and 19. This is our stem. These are the leaves. So for the anvils, there was only one number in the 150 range, and it was 158. So we put 8. Remember, with your left-hand side, you're working from the middle out. So 158. And there's only one value in that range, so I put it over here. For the 160s, there were 2 values, 5 and 9. So make sure, again, you're working from the inside out, the stem out to the leaf. So 165 comes before 169. I put a little comma there to help separate my values so it helps me separate them. You don't necessarily have to put the comma, but I like to put it. Then for the 170 range, there were 4 values, 170, 172, 173, 175. Especially with the anvils, the numbers are all mixed up. Make sure you carefully look through it, write down your totals, count them up. So I had 1, 2, 4, 3, and 1. When I add them up, 1 and 2 make 3, 3 and 4 make 7, 7 and 3 make 10, plus 1 is 11. I know I got them all. Sometimes it's easy when the numbers are mixed up to lose track of one of those values. And if you miss a number, it throws off all your statistics. Okay, so just double check to make sure you have them all and that they're in order from least to greatest. Notice when we get to the Brecons, nice for us, they were already in order, so it makes it easy to fill in the right-hand side of our stem and leaf plot. They didn't have any values in the 150 range. That's okay, just leave it blank. They have one number in the 160s, 166. Notice in the 170s, they had 2 values of 172. Make sure you put both, okay? Because if you don't, again, it throws off your statistics. So the 172 occurred twice, and also the 183 occurred twice. And then we had a 192 up here. So again, write the number. There's 1 of these, 5 of these, 4, and 1 of those. So 1 and 5 is 6, plus 4 is 10, plus 1 is 11. Said there was 11 in each one. So we were pretty certain that we did it right. Now let's see what the instructions that go along with it after we've drawn the stem and leaf diagram. Now it says, find the median and the interquartile range for the anvils. Okay, so the median and interquartile range for, there we go. The anvils are here on the left, and it wants us to find the median and the interquartile range. So remember, there is a total of 11. So the nearest even number is 10 divided by 2 is 5. So this splits up into 5 and 5 with an exact middle, which is the 6th term in. So remember, you go from the stem outward. So 1, 2, 3, 4, 5, 6. This one here is our median, the sixth one. If you count backwards, 1, 2, 3, 4, 5, 6, you still get to the same number. You can also use this here. Here's 3. So if you already know 3, especially when you're dealing with big sets, instead of counting 1 per 1, it might take a while if you're working with like 60 values. So use these side ones. The sixth one is going to be somewhere in here because here's already 3. So then you just go to 3 more, 1, 2, 3. So 3 plus 3, 6. So there's different ways of doing it, but these numbers on the side can help you find those quartiles a little bit more quickly. So that's the median. So we want to put that. The median equals 3. This is our anvils. Median equals 3. Now we want the interquartile range. So we already split this up into half. Now we have to split it up into half again. So this 5 is going to split up again into 2 and 2 with an exact middle. The nearest even value is 4 divided by 2 is 2. So you got 2 and 2 on both sides with an exact middle. And that exact middle is the third term. So we go in here to the third term. Here's the first, here's the second, here's the third, there's quartile 1. If we go from here, remember that was an exact middle, so we don't count it. So the 5 would be the first one, second one, third one would be this one right here. If you count backwards, 1, 2, 3, you still get to that one there. So that's our Q1 and Q3. So our interquartile range is 181 minus 169. So that gives us, what, 12? So 169 plus 10 is 179, 180, 181. So 181 minus 169, interquartile range of 12. So that's our 2 answers from this data set. Notice again, the data could be random. It could already be organized. You need to make sure it's from smallest to largest. So this then again would be our minimum. It didn't ask, but minimum. Here's the maximum. Find the quartiles, and it just helps organize the data. Now we're ready to do analyze it for statistical information. So this is our first method of data representation, organizing the numbers in a stem and leaf plot. Okay, so it's not really that difficult. You just need to remember some of the details, like how to find the quartiles. Make sure you remember your labels and make sure you write the key. We did not write a key for this, so I'm glad I reviewed it. We need to put our key down because it asked us for stem and leaf. So don't want to forget that because you would lose a point. So here is our key. It doesn't matter where you take it from. Since it is a back-to-back, you can't use the 15 because it doesn't show the right-hand side. You can't put 0 there. 0 is a number. This is empty. So what I'm going to use is I'm going to use this first place that has a left and right. So I'm going to use 5, 16, and 6. So the meaning of that is 165 for the anvils and 166, I'll put it down here, for the breakin. So you need to put the meaning, not just the key. You need to interpret it. That way people, when they're looking at it, know that this is 165 and not like 0.165 or 16,500, you know, so you have to show the meaning. So 165 for the anvils, 166 for the beacons, and so make sure you put the key. So now I think we have everything. We have the labels, we have our stem, we have our leaf, we have our key, and we were able to answer the questions. So again, thank you for joining me, and look forward to seeing you next time at part 2 when we look at the box and whisker plot.